All right, Earth Science time. We're going to talk about... I will look at your drawings. We're going to talk today about surface and groundwater and usage. I don't know. I wish I'd phrase that differently. How about surface and groundwater use? That seems more like how a person with a college degree would say it. Okay, surface and groundwater use. We're not only talking about their usages, we're talking about surface water and groundwater in general, and then we're talking about how they're used. Why did that not work? I want the picture in picture. I want the picture in picture. There it is. Okay. Where is most of the water on Earth at any given time? Yeah, the oceans. Most of the water on Earth at any given time is in the oceans. I was going to draw a pie chart, but there is a pie chart in your explorations, which you've seen, and there's a pie chart in your book, if you still even own your book, which you could see. I'm going to show you this. Oops, I always forget which way to move it. This is the pie chart. Credit Houghton Mifflin Harcourt, not a sponsor. Okay. But you can see on this chart, and can you see it? Can someone have either their textbook open or their explorations up so that we can all look at this chart together? This is labeled near surface water, which means like not the water in the bowels of the planet. But of all the surface water on Earth, or near the surface water, how much of that is oceanic and how much of it is fresh water? I'll tell you while you're trying to find it. We'll talk about the next one as a question. 97% oceanic water and 3% fresh water. So right there, most here even being an understatement, almost all of the water on planet Earth is salt water. It's ocean water. Of the fresh water, of just the fresh water, the pie chart comes out from that, of the fresh water, how much of it is in ice caps and glaciers, does it say? 79%. How much of it is in groundwater?
Is it in exploration?
So 79% ice and glacier, 20% groundwater. So how much of that would be just surface fresh water? Well, 79% is accessible surface fresh water. And then of the accessible surface fresh water, what's the major constituent there? Lakes. And then 38% is soil moisture. And then the remaining is rivers, water vapor, and 1% is water within living organisms. I think it's nice that they included that, because you yourself are a bag of mostly water, so that's cute. Even some of our Arby's employees that we talk about quite frequently are mostly just certain shaped bags of mostly water. So you can think of them that way. Oh, I don't know your life. Okay, but the point of that is that where is almost all the water on Earth? In the ocean. And then even of that that's not in the ocean, where is most of that? Yep. And then even that in glaciers, where's most of that? No, you're missing one. Like what's the biggest thing? Yeah. What's the biggest thing here you could use for your own, or probably maybe not you. Once again, I don't know your life, but human beings. What's the biggest thing here that human beings could use for their bathing and drinking and happiness? Aquifers. Probably aquifers. Probably aquifers. So we're going to spend quite a lot of time talking about groundwater. And we need to be careful when we talk about aquifers and groundwater that we differentiate those two things. First, we're going to touch, just like, review the water cycle. But I think we talked about this before, but the verb that's part of the water cycle, actually it's a noun related to a verb, but what is the part of the water cycle that kind of connects groundwater to the whole thing? What is water able to do that makes it into groundwater? Do you remember the verb we used? It was in your last lesson. I remember writing it on the board. No, it's almost the opposite of that. Not quite, but what happens to water on the surface that can cause it to become groundwater? It's also on the chart of the water cycle in lesson 2, exploration 1. No, we look at where it becomes groundwater. What's happening to that surface water that's causing it to become groundwater? Infiltration. So here's the hot question that many people misconceive about this, about water usage on our planet. How are surface water and groundwater related? Well, the answer to that is the topic today. Stand by. Okay, so the answer to this question and the exploration of this question is all part of a science called hydrology, which, as you probably understand already, is what? The study of water. The study of water. Hydrology, the study of water. The water cycle is a big part of that. We talked about that last time. So how are surface water and groundwater related? Well, let's try to answer that. What is one way in which they're related? I mean, there's one thing we just talked about is that what verb relates these two things together? Infiltration. Infiltration. Let's get a little bit more specific about that, though. Do you think water can infiltrate into rock all the time? No. So under what circumstances does water infiltrate into rock, would you guess? What does it depend on? Okay, so it depends on rock type, and we'll talk about that more. I'm going to put 2 things here. Actually, I'll probably put 3. What else does it depend on? Well, it may be thought of another way. What else might prevent water that's on the ground from infiltrating, from becoming groundwater? Okay. Evaporation. I'm going to put evaporation rate. What else? When else might the water not infiltrate? I can think of at least one other reason. Let me give you an example. This recent snowfall, when it melted, do you think all of that became groundwater? Even if the rock type was right. Well, let's say my front yard, or your front yard, or anyone's front yard. The rock type is probably right, or at least maybe we shouldn't say rock because my front yard at least isn't made of rocks. We could say the substrate, the stuff that it's going into, was right for it to infiltrate. Because some of it, there's a certain rate of evaporation. But why else? Is there water in your yard right now, do you think? Yeah, so why hasn't it infiltrated? Because it's evaporating? Well, it's obviously not, because it's just sitting there. What's it doing? It's just sitting there. Why is it just sitting there? Yeah, because what? Because what it's going into is... Say full. Say full. Yeah, it's full. Yeah. So the amount of groundwater... Oops, let's spell it right at least. Already present. I'll just put that. Already present. Because unlike when you have normal water, oh, and make no mistake, these are both affected by gravity. I shouldn't have to point that out, but these are both affected by gravity. It seems almost facile to say that, like it seems like anyone should know, but it is it's sometimes hard for us to remember. The groundwater will flow from high head pressure to low head pressure just like surface water does, but it does. But even though that's true, even though it does flow effectively downhill, that's not the whole truth. But even though the groundwater does flow, it doesn't flow nearly as fast as surface water. And so it's sometimes easier for us to forget. But the reason that water is still in little puddles in your yard is because as it infiltrates through the substrate, it can only do that at a certain rate. And so some of it is kind of like left behind, basically in a waiting room trying to get through, but it has to wait till its friends infiltrate too. What are some rock types that might affect this? They have special names that we use, and this was your belt work. I'm talking about, and you're right, of course we can say things like, how does gneiss affect the infiltration of rock? How does sedimentary rock? But I'm talking about for these. Yeah, but aquifer is one. And what's an aquifer? Yeah.
that stores enough water.
Yep, can contain water. So it has pore spaces, and it doesn't have to be rock itself. It could be unconsolidated material, which means it's not stuck together, it's just like a pile. But it's a unit of earth material that can contain water. What do we call it if it can't contain water, or if it stops water's flow? Aquiclude if it stops the flow of water. And then there's one kind of in between where the water will go, but it will slow the flow of water, and that's called an aquitard. Thanks, Camden. That is hilarious, isn't it? Slows the flow of water. You laugh because obviously that sounds like a funny word in your vernacular. But why is it called this? How is this related? What does that suffix mean? Okay, well, what's this suffix mean? First of all, what's fur mean? It's the same root word as Christopher. Someone's named Christopher. Yeah, they're full of Christ. Exactly. They carry Christ. So aquifer is a unit of rock that carries or is full of water. It doesn't have to be full, but it can contain water. What does an aquitard do?
It
Slows down the flow of water. And what does an aquiclude? We use words like include, and that's kind of the opposite of this. But what can an aquiclude do? It can, I would think of it as it can exclude water. It can prevent water from going through it. How does groundwater get there in the first place, then? I love this little diagram on page 4. I'm going to show it to the camera so that if you're watching... Oh, gosh, I'm so bad at this. My job. Everything's backwards. Look at... Ooh. Look at this diagram. How does groundwater get there in the first place? Okay, yeah. Through infiltration. There's usually a certain area of recharge. So for instance, let's have a little, we're going to try to draw much in the book. Let's say that this town here, there's a town, by the way, BT dub, there's a town. This is a great drawing. Let's have this down here be some kind of like basalt or granite or something that is an aquiclude. This down here is an aquiclude. We'll have this layer here be sandstone. Can you guess which of those things sandstone probably is? Not all sandstones, but what do you think sandstone usually is of these three? Well, what physical property of these makes them the way they are? You'd already said the word. What? No, it's not their rock type. It's how you said the word though. How much easily the water can go through it is its. Starts with a P. Permeability. So it's the permeability of these that determines which one they are. And so what do you think sandstone probably is of these? Just guess. It's okay. There's only three. You can't be that wrong. Do you think sandstone has sufficient pore spaces that water could go through it? Probably. So we're going to call this an aquifer. Oh, well, I guess that's fine. I'm going to draw another one on top of it, though. And we're going to call this one aquitard. Maybe it's, I don't know, shale wouldn't really work. Maybe it's siltstone. Let's call it siltstone. Eventually the water can get through, but it takes a long dang time. It has low, what we call hydraulic conductivity. The water slowly goes through it. And in this one, we're going to say this is unconsolidated material, or maybe sandstone, but something like that. This is going to be another aquifer with high hydraulic conductivity. This is unconsolidated material, topsoil, etc. Well, that's an aquifer. And then these are going to be aquicludes as well. We'll say shale. We've talked about the geological symbology before, right? Like what these little symbols represent, where the Circles are gravel deposit, etc. So if you live down here, here's you. This is your town. This is Crawdad. We're gonna actually let's not use Crawdad because this is not necessarily the way that hydrology works here, and I don't want you to get confused. So what's a good name for this town? It's not Crawdad. Actually, Crawdad would be fine. I don't want you to think it's Crawford, but what should we name this town? Crawfish. Oh, good one. Crawfish. So this is the town of Crawfish. How do the residents of Crawfish get their water? Well, what are the choices in general? How does anyone in the world get water? Well, give me some options.
They get it from like a lake.
Okay, a lake. Yeah, surface water, basically. A lake or a river. Sure, that's one way. What's another way?
They go to the store and buy it.
Store and buy it. That's a great way that we should talk about. No, what else? I mean, generally.
Water from like a well.
Okay, a well. That's what the one I was looking for. That's what we're going to get to in a second. Okay, so but surface water, a well. What else? Let's think of some other ways, just because that's actually that's the end of this chapter. Some other ways to get water, some water resources we can use. Well, surface water. What else? How do you think someplace like the Sahara Desert or the Levant or the Arabian Desert, how do you think those people get water? Okay, a well. Again, probably. Yeah.
They get it from
How could you, like if you were in a survival situation like Bear Grylls,
in any place that you would have access to water.
yeah, surface water probably. Or you could collect rainwater is what I was getting at. There's also such thing as desalinization. Like if you have a water distiller, like we have in the lab, and you put seawater in there, that'll make pure water for you. So desalinization. But that's pretty much it. I guess technically chemical reactions, I mean, we talked in chemistry about how the reaction of hydrogen and oxygen, for instance, makes water. The decomposition of hydrogen peroxide makes water, but those are probably pretty few and far between. Some organisms have water. And, you could get a cactus, and that would be a source of water. But primarily, the number one way, probably well digging. The number two way is probably purification of surface water. So we're going to say this town digs a well. Well, looking at the geology of the area, how is water going to get into this system? Well, what's the verb, first of all? Of course, the water must do what to get into the groundwater? It must infiltrate. Where does it come from before it infiltrates?
Is it coming from like an aquifer or something?
No, it's before it precipitates. How did the water get here in the first place? There is water in these aquifers, but
Water cycle like they either
yeah.
into the ground.
Yeah, some precipitation probably. So there was precipitation. But if we look at this, and the precipitation falls everywhere, we'll say an even amount of precipitation falls all over the area around Crawfish. What happens if the water that falls, well, let's just start from the left. What happens to the water that falls here? Right here, at this point, what happens to this water? Yeah, it'll run off this direction. What happens to some of it will flow off and some of it will evaporate. Well, let's discount those. But what happens to this water that falls right here? I see I've drawn this in this way to make a point here. Can you see this all right? I'm sure the camera probably can't, but water that falls right here, what verb happens to it?
It's runoff.
Well, some of it does, yeah, but I've drawn it. So I've tried to draw this aquifer such that you can see that the cap of this hill is sandstone of the same unit as down here.
So it also
Yeah, it infiltrates. So some of this will infiltrate down to here, and eventually, over a long period of time, this recharge will fill up this aquifer here. So this aquifer is full of water. Since this is just an aquitard, eventually this aquifer will be recharged as well. Okay, what about water that falls right here?
it also will.
Can this one infiltrate? No, because this is an aquiclude. So what happens to this water right here? It runs off down into this. So what happens to water that falls anywhere on this area?
Is there like a stream?
Yeah, it'll fill up this small layer here as an aquifer, but most of it'll probably end up running off because amount of groundwater already present. As this aquifer fills up, the water will mostly run off. So if you're in this town, if you're in Crawfish, how are you going to dig a well? I'm going to draw this in red. How are you going to dig a well? Would you like the well to go into this layer, this aquifer here, right on the surface? Maybe to some extent, but why would it not be the best idea? If I just dig it into this surface layer right here. What happens as I pump water out of it? Is an aquifer limitless? No. Eventually the water will be gone. Okay, so if I dig the well this deep, is that going to be a good idea? No, because it's going into the aquiclude. That won't work. I won't get any water at all. What if I dig it this deep? Well, this is actually the best idea because this has a huge recharge area. It's coming from this large aquifer that is recharged by everywhere in this mountain range, for instance. So this is the best well here. This is the good well. But any of these wells will cause some amount of drawdown. Let's write that word down. Drawdown. The lowering of the water table. Have you read about the water table in your explorations? Okay, lowering of the water table due to wells pumping.
It's like the upper zone of surface.
Yeah, let's cover that real quick. I assumed you knew about it, and I'm just going to draw it over here. Just a real simple diagram. We'll say this whole thing here is an aquifer, sandstone, for instance. The water table is just the line at which everything beneath it is saturated. We call it the zone of saturation. Zone of saturation. With what? Saturated with what, by the way? Water. And the area above it is called the zone of aeration. Basically, above the water table, the pore spaces in rock are filled with what? No, above the water table, they're filled with? Well, yeah, but what are the pore spaces filled with? Not rock. Air, yep. And then below the water table, the pore spaces are filled with? Good. Then when a well is dug, I'm going to draw my well in this diagram now. When there's a well here, as the well pumps up water, since the water doesn't respond instantly, like it does if you just use a straw to suck water off a table, there we go. It'll draw down a little bit. And we get this thing, which is a cool name for a band. I love this. This is called the cone of depression. Is that a threat to water quality? Yeah, is it? Do you think this is a threat to water quality? Well, what's going to happen? Let's take it to its extreme. What happens if I do this too much? Eventually, what? Well, yeah, I won't have any water at all. My well just won't pump. And if I do it too much, the water was kind of providing an adhesive force for the ground, and the ground could collapse, and that's called subsidence. There's also, of course, pollution that's an effect of water quality. Your book goes on to talk about, which we already talked about. There's a whole section on how human beings impact this situation, which you need to read about, but we've obviously run out of time. The bell rang. So get this stuff down. Ask your questions. That's the end of the discussion. Do you have questions right now, though? You're good? Okay.